looked at most of the homework? One came in like few minutes ago that I will take my time to look at and respond. And I have already shared my feedback to individual ones, but there were few things I think it is worth discussing. So let me get to that part. So, why is it not showing the, okay, when I'm trying share screen, it's not showing the files. Like I want to project a PPT and it's not showing that. Any idea how this can be countered?
Can you make Swati as a co-host so that we can?
I may cause Swati as a co-host. Swati, can you check me?
Still, it's only based. No, not yet. See, usually it is like the whiteboard something, and then all the files, the windows you have opened, right? Those open windows part is not there.
Can you check, are you in the which tab? Basics, advanced, something?
Basic. Usually it is there in the basic. Maybe let me try portion of the screen. I don't know. Okay. Okay. This might work, at least for now. Can you see the PPT?
Yes.
Okay, let's go with that. So yeah, as many of you have mentioned, for commutativity of addition, if you have two numbers, instead of adding the bigger number to the smaller number, it's easier to add the smaller number to the bigger number, especially for mental math. So yes. Now, what I want to highlight is, apart from those mental math aspects, it actually helps us or is very important in some of the standard algorithms that we do. So let's take this case of 17 plus 5. Okay. See, when we teach them to do this, right? What do we do first? We add 5 and 7, right? And get a 12, which we kind of put down like this, and then add this, right? So in a way, what we are doing is we are basically thinking of this as 10 plus 7 plus 5, and not that we are adding the 7 and 5 together. So essentially we are doing this. Okay, we are applying associative property. Okay, and we may not pay attention to it, but it is there. Nothing else allows us to do that. Okay, now similarly, in case of multiplication, okay, and for multiplication, this is, I mean, we say it, right? Whenever you multiply with a multiple of 10, like 50, 40, 30, 80, you multiply the number with that 8 and then put a 0 at the end, right? Or if you multiply something by 200, you double and then put 2 zeros. This is something we commonly say. Now, what is happening is we are basically using the associative property. Now, it's fairly late that I understood that, this is what is happening, right? And then what we are doing actually is, this is what we asked, right? You multiply 43 and 5 and then you put the 0. That's basically putting the 0 at the end essentially means you are multiplying by 10, right? So again, we are applying associative property and not aware of that we are doing it, okay? Now, the distributive property, however, is more well known in the sense that that is what we need to do multi-digit multiplication. So, for example, when we are doing, let's say, 372 times, let's say, 86, okay? So what comes in this first line is 372 times 6. That's what comes as the first line. Then in the second line, we get 372 times 80. And there, of course, we are going to use the associative property as before. And that is why, because we are multiplying by 80, the units digit is 0 and we need to put a 0 and nothing else. Okay. And then we add. Okay. So this is pure distributive property. Of course, we break this along place value line as 6 plus 80. Okay. Now, distributive property has many other application also, but this is what is probably the most crucial. Now, the homework I have for you regarding this is, you're all familiar, right? AB whole to the power n is equal to a to the power n times b to the power n. So when you do this with, let's say, a natural number n, so n is 1, 2, 3, 4, some number like that, counting number, non-negative counting number. Okay, and you can take, okay, positive counting number. Okay, now, and AB can be, let's take any real number. AB can be any real number, right? So, I mean, what does AB whole to the power n expand out to? And then how can you basically get it to a to the power n times b to the power n? Okay, think about which of these properties, commutative, associative, etc., you are using and maybe how many times. Okay, so that's the homework. Now, any question, comment, anything? Okay, so then as we go to the person had mentioned some of the graphs for data types, and some graphs were not mentioned. So we will discuss that. But before that, I would like to, I mean, last time we kind of got into graphs before going into data, etc., what is data and all of that. So today I will talk a little bit about data and then go into data type and how it influences type of graph, etc. By the way, I haven't got any question from you. So if you have some question, definitely put them in the chat and we will definitely discuss them.
Now or at the end?
If you keep writing, then, after this slide, we can take them up.
I have written. I'll just put.
Yeah.
Yeah.
Okay. See, one very important aspect of data is that it has two parts. There is always a who and a what. Okay. So hang on, I need to shift things around a bit in my screen. Okay. So, yeah, okay, much better. Okay. So, for example, if you are collecting information about different people, then the who are going to be each of this person, and the what can be their attributes, like let's say their educational qualification, or their height, or their blood pressure, or whether they have been vaccinated or not, both vaccination or single vaccination. So in that case, it's very clearly the people are who and their attributes are the what. Okay. And you can, from depending upon each attribute can be called a variable, and each of that can be qualitative or quantitative. Okay. So for each variable, so for each thing, you figure that out. For example, when we ask the question whether vaccinated or not, then it's a binary categorical thing, yes, no. Okay. Now if you bring a bit of nuance, because there are two doses of vaccination, right? So you can completely quantify it into 0, 1, and 2, like not vaccinated at all, got first shot, got both shots. Okay. So then it becomes a discrete new quantitative data, right? So you have to see how it is said and what exactly you are capturing. For example, if you want to figure out which state this person is from, that will definitely be a categorical thing, right? If you look at education qualification, then that can definitely be ordinal data. So that way there are, you can figure out. If you are talking about height, weight, etc., blood pressure, those are again quantitative. And height, weight definitely are continuous. Blood pressure, I would technically put it as continuous, even though it's never written as a decimal or something, but it's technically a continuous. Okay. The way it gets reported is obviously in whole numbers, but that kind of rounding we do all the time. At the same time, we need to keep in mind that it's not single number. So you cannot combine the numbers together. So when we talk about blood pressure, that's a data with two variables, the systolic and the diastolic. Okay. So it can be like that. Okay. And we have discussed that how phone number, PIN code, even though they look numerical, they're actually categorical because they act as label. Okay. Not as quantity. They do not represent any quantity. Whereas in case of vaccination also, the 0, 1 to actually represent a quantity. Okay. So this is a very, very important one. Now, the question that has come up is why pie chart is generally called an inappropriate graph type to convey the data and is avoided nowadays. We discussed this partly. Pie charts are good to figure out proportions. Okay. And if you have fewer categories, okay, just 2-3 categories, etc., then it is a good idea to see what are the relative proportions. Is there anything which is more than 50%? Is there any two which make that more than 50%? Okay, to give a sense that if you have, proportionately how are they related, especially if you have binary data, just yes, no, male, female, etc., etc., then it's a very good idea to use pi, because then you are, and you want to focus on the percentage, because it gives you that proportion much better than, it conveys that quite well. Now, suppose sometimes you may want to draw complicated graphs. For example, you may want to see whether number of women in engineering has changed, or the percentage of women in engineering has changed across the years. So you may want to look at this data across time. Now, one way of doing that would be, and I'll just annotate very roughly to give you a sense of how this kind of data may look. Okay, so you will basically draw, the time. This will be, time, and then what you can put is, you can put pie charts here for each year or each 5 years or whatever. You can put pie charts and you can see if the proportion has increased or not. Okay, it can be done through line graph also, but this can also be done through pi. Okay, because you are looking at the proportion, not like number of. If you want to look at number of women, then or number of total applicants, etc., total how many people take up engineering now, has it decreased now, etc., then of course a line graph will be much better. But if you are interested in the percentage or proportion, then pie chart will convey that much more clearly, and it will very clearly say that yes, we are talking about the proportion, percentage, and that's where the focus is. Okay, so it has very specific application. Okay, now one of the main things, I will come back to this a little later after I go to the next slide. Okay, but I'll definitely come back to this, and then I think it will become even clearer. Okay, so let me go to the next slide. See, these are, and we may not complete this table today, but we will do it over the maybe the next few ones. Okay, which reminds me, next Friday, same time, 11 to 12:30, I have a pretty critical meeting with some external audience. So can we shift this to some other day, let's say maybe Saturday, for just next week? Is that possible?
I think, yeah.
So, I mean, you don't have to, agree completely or, tell me right away, but just do get back after consulting your schedules and etc. Okay, please confirm. Okay.
Yeah.
Okay. So now we can definitely make pi for this one and this one. And you probably already know that we also make bar for these two. Okay. Now, do we make bar for quantitative data?
For discrete data, we can use.
Yes, but now, okay, so I'm going to put it within bracket and I'll tell you exactly why. Okay, but what about
Histograms.
come again?
Histograms.
Yes, for continuous data, we do use histogram. Now, here is something, and I should have, have 1 second. I'll insert a table, one row. Okay. The thing is, in these, you keep it ungrouped. You don't club together things. Okay. But when it comes to discrete, for example, think about population. Okay. Now, in a country like India, whenever we talk population, I mean, if we talk population of, say, blocks, okay, and we have so many blocks, so then this population becomes, even though it's very discrete, you cannot have a population of 70.05 human beings, right? It has to be a whole number, and therefore by nature, mathematically speaking, it is discrete. But when we talk about population, and if you want to, collate the data, organize the data on, say, all blocks of Tamil Nadu, right? How many blocks are there in Tamil Nadu? Does anybody know?
District, right?
No, each district has blocks. So, okay, how many districts?
32.
Come again?
32.
42?
32.
32. Okay. Okay. So it will probably be safe to say, if we take on average, let's say 5 blocks, which is probably too less, but around 150 blocks, maybe more. Okay. I mean, you can look it up. So when you want to look at the population of each block, okay, or even if you look at it district wise, you will get 32 different numbers, and it practically may not make too much sense to to consider each of them separately. So that is why we often group them together, those frequency table with class intervals. So that's what happens. Okay. And if you make any frequency distribution with class intervals, then that is called a grouped frequency table. Okay. So in case of discrete, it can be ungrouped or grouped depending upon the situation. Okay. In case of continuous, it's most of the time it is grouped. Okay. Unless you have like very few data values. Your total frequency is very less, it will always be grouped. Okay. Now, whenever you have grouped, then histogram is the choice of your display, a graph. Now, there is one graph which is very closely linked to histogram, meaning that if you can draw histogram, you can draw that too. Anybody remembers that graph?
The bar chart itself is close.
No, it's not bar. It's not bar. It doesn't look at all like a bar. It is super useful when you want to compare the data for 2 distributions, or rather compare 2 distributions. It's difficult to do that with histogram. Max, what I have seen somebody do is something like this. They will have a histogram which goes like this, and they will have another histogram kind of like this. Okay, that's the most I have seen. I mean, of course, it can be done this way also. You have a histogram like this, and you have the corresponding one, and you can definitely compare. Okay, that's one possibility. But then you can do it only for 2. If you have to compare, 3 such histograms, then that can be, quite difficult. But with this other graph, you can say sister of histogram or brother of sister histogram, you can do it very, very easily. Okay, look up class 8 and possibly 9 textbooks, okay, wherever they are discussing graphs. So this is the second homework of today. First homework was the A, B, that thing. So homework 2 is look up the graph closely associated with histogram. Okay. Okay. And if you can find it while I talk during the next half an hour, that will be awesome. Okay. Now, whenever you have, now in case of discrete quantitative, your bars represent single numbers, right? So they will be like 0, let's take the vaccination thing. It will be like this, right? 0, 1, and 2, and you want to have bars on top of them. Now, what I have seen people do now is, because it is no longer, it's just a point, right? Not an interval. What they do is they make the bars into sticks. Okay. So it's a bar, except it has no width. Okay. Which makes kind of perfect sense, because 0 occupies just a point, not an interval on the number line. Okay. So it hasn't entered school yet, but this is a very valid, mathematically correct representation of things. Okay. If you can read a bar, you should be able to read this. Okay. So I'll modify it here. This is bar, and I'll put stick diagram. Okay. And when it gets to histogram, you have a full interval, and therefore you have those connected rectangles. Okay. Now, for this grouped data, there is another kind of graph which is used very little. In fact, the potential used is not really harnessed in the textbook, which it should have been. And that comes only around class 10 at the end of the chapter for NCERT. Anybody remembers what that is? Okay, that's fine if you don't remember that. It's called ogive. It's the graph of cumulative frequencies. Okay, there are 2 ogives. Okay, so one ogive will rise like this. Another ogive will come down, and it will be a mirror reflection. I may not do justice to it, but it's a mirror reflection of this one almost. And that can be very rigorously shown. Okay. Hopefully it will come out in the November issue of At Right Angles. Okay. So these are called ogives, and they have some use. Okay. I'm not going to say a lot, but they do have some use. Okay. Now, the next important thing is whether you have a bar or a histogram. Let me now draw some histograms. Annotate and draw some histograms. Any questions so far? Oops, sorry. Okay, so When we think of bar, it will look like this. Right? Something like this. Now, in case of categorical data, these bars can be interchanged. There is no fixed order, so you can put them in any order you want. Okay, now we have a very good question. Okay, I'll take that after I discuss this a little bit. Okay, now in case of ordinal, it will look kind of like a bar, but then the order of the bars are kind of fixed. Okay, you cannot interchange them. What you may do is you can completely flip them over, right? And get a mirror reflection of what you have here, but you can't, put the tallest at the front and you can interchange like that. Okay, so that is fixed. And then we come to the numbers. Then it is, pretty strict, like the order is very, very defined. If you have sticks or whether you have histogram, it's like, the numbers have to be in increasing order, right? Otherwise it doesn't make sense. Okay, so okay, something like this. Now, when you see this, there are usually three things we are interested in for any such distribution. And they are called the center, spread, and shape. Now, center is something that is discussed in class 7, then maybe a little bit in 8, definitely in 9, 10. Spread is discussed very minimally in class 7 and repeated in 9, but it's actually taken up in class 11. And shape has not been discussed pretty much anywhere. Okay. So what happens is center is basically what you want to, where is the center of the graph. Okay. Now, in this case, there are three ways of finding the center, which are, in case of quantitative, which are mean, median, mode. Okay. And for various kinds of data, we can use various things. Some are more appropriate than the other. Now, if it is a qualitative data, then obviously you cannot calculate mean. Okay. But the question is, you can calculate mode for both. Okay. If it has single mode. Okay. If it is bimodal, then of course you can't. Or you can report two modes separately. You cannot combine them to be one mode. Now, I have a question for you. If you consider the ordinal data, do you think it is possible to find median in that?
Yeah, I think we can find.
Okay, you can. You may get into a little bit of trouble, okay, if the median is in between two bars.
Yes.
Okay, because then adding and taking the arithmetic mean of these two values may be a bit difficult, but at least it gives you a sense of where on this line the median is. So it's not like completely useless. Okay.
Yeah.
So yes, thank you. So far, to whoever I have presented this idea of a median for ordinal data, nobody has refused. So let's hope and pray, one, ordinal data does enter the school textbooks, and two, that people also talk about the median of it. Okay. Now, as far as shape is concerned, in this case, because the bars can be interchanged, is there any way to discuss shape for categorical data?
It can take any shape.
It can take a shape, so it is not applicable. Okay, you can at the most talk about modality. Okay, but you cannot talk about anything else. Okay, you can talk about modality only. How many modes? Okay. Okay. Now, in this case, of course, in this case, you can think of a shape. In both cases, you can think of it whether it is symmetric or skewed. If it is not symmetric, then it is skewed. Now, there is two terms. One is right skewed, left skewed, or positively skewed, negatively skewed. I always forget them. Now, what I do remember is, see, whenever you have this, usually they're like a lump and they have two tails. Okay, which tail is longer? That is very obvious. That I remember, and that actually can come out also from mean median mode. Okay, we won't discuss that today, but we can, I mean, those are quite interesting. Okay, so maybe here I can just simply merge instead of writing twice. Okay, it wants me to do things the hard way. Fine. Okay. Okay. Now here, in case of ordinal data, I mean, you see this rough graph here. Do you think you can, I mean, it's possible to talk about shape?
Yes. And
Yeah,
and it
it
will
is.
stay same. Like it will, the modality will be there even if you interchange the
Yes,
reverse it.
modality will definitely be there, but what about symmetric versus skew?
It can be skewed.
This one does look skewed, right? With maybe longer tail this side, right? It's like, it is definitely lopsided, and you can see like this is more and this is kind of less, right? So in this case, I think you can talk about both skew and modality. Again, not too many people talk about it, but I have seen at least one report now where they have used in an experiment, a kind of a social experiment or something, where they have used these kind of bars, okay, for ordinal data to kind of look at how things are in terms of, they have this control group and experimental group. So some people were given a certain privilege or some intervention, and some didn't. And how did that impact the two sets? Okay, did the intervention help them or didn't? Did it had an impact? So they were trying to do that, and they were doing it through two such bar graphs for each set of people, and they had several such pairs, and they were talking, they're literally talking about whether there is a significant difference or not. Okay, so I am also myself not so familiar with how to quantify this precisely, etc. But looks like, people are taking these graphs in a more, and dealing with them, more seriously. Okay, so that is there. Now let me take this question now. However, let me get to the first question first, complete it, then come here. From these kind of data, you get this distribution, you get a sense of center, spread, shape, all of them. Okay, spread is basically is it two together or two spread apart kind of, okay? But this is something that will never ever come from a pi. And possibly that is why you can call it inappropriate, okay? I mean, inappropriate is too broad to categorize. Like, why inappropriate is because it doesn't give you a sense of a distribution as such, okay? Because you see, in these things, the data value axis is straight, right? In case of a pi, it is wrapped around, okay? So that is why, you can make pi for these two as well, for discrete quantitative and continuous quantitative. I mean, nobody can prevent you if you want to make one. And in fact, I remember some people making it, okay? And it can have some use, but usually what we are interested in terms of center spread shape, especially for quantitative data, that doesn't come from pi. Okay, and that is why usually pi is not used for quantitative data. That is why it has less use. Okay, so avoided nowadays is I don't know if I'm qualified to answer that. Maybe a practicing statistician can. In some cases, pi are used more. For example, as I said, give the example of budget compared to how it was when we were children. So I honestly don't know if whether it is avoided nowadays more or etc. But basically, this is what pi can do and cannot do. Okay. Now coming to the next question. Yes, so there are two types of hierarchy, you can say, not hierarchy, let's say. You are asking basically pedagogically, is there a hierarchy? Yes, there is a hierarchy. We'll come to that, then let's look at this. Why take x-axis horizontally and y-axis vertically in line graph? Okay, hello, x-axis horizontal and y-axis vertical is a convention in the Cartesian plane. What you probably want to say, and please correct me if I interpret this wrongly, is that the frequencies are usually put along the y-axis. Okay, and the data values are usually put in the horizontal axis. Though I'm pretty sure you have seen bar graphs which do the other way, I have just roughly drawn two histograms where the vertical axis is the data value axis and both histograms are spreading out along the horizontal. Okay, so as far as statistical graphs are concerned, you are free to interchange the horizontal and vertical axis as you need. I think it is perfectly okay as long as you label them correctly and you don't get confused yourself. Okay. As far as proper line graph goes, which usually goes along line graphs which show change of anything over time. Okay, how a temperature fluctuates throughout the day, changes in stock prices, how in a one-day match the runs grow, ball by ball, over by over. These are all good examples of line graphs. There, it makes sense to have the horizontal axis as the time axis, okay, and the vertical axis as how things are changing. Now, this is connected to the fact that later on, or whenever we have, this whole notion of independent variable and dependent variable. This comes a little late at 11, 12 when you talk about functions, y equal to f of x, those kind of things. The independent variable, the x, is always along the horizontal axis, and the dependent variable is along the vertical axis. So that is where it kind of makes sense to have the independent variable or the data values along the x-axis. So if you want to stick with only one, do that. As far as school textbooks are concerned, only in case of bar graphs, I have seen that they have been both horizontal and vertical, vertical and horizontal, at nowhere else. To address this for children who are getting confused, one idea would be that if they see a bar, if they see bars like what we have right now drawn, then I think it should not be a problem. Now, if they're having difficulty dealing with bars, which I'm now going to draw, let's say which look like this. Okay. Ask them to kind of rotate this picture. Okay. If it is on a piece of paper, or if it is not, if it is on any screen or any book, ask them to rotate it. Okay. See, if it is bar, then this is all data values, they can be interchanged, etc., etc. Because school textbooks right now have only categorical. Okay. So that's fine. So if you just rotate it, then that will give you, then that will just help, right? Then it will start looking like this one here, the red one, and that should take care of it. Okay. So I think with some practice, they should be able to deal with this. Okay. Now, did I answer this part of your question, Shiva?
Yes, Swati, I got it. Hello.
Okay. Now the hierarchy. Quantitative data comes out later. So it's usually started with qualitative data, categorical. The first graph they start with is pictograph. Now there are two categories of pictographs. So let me go to the next slide, clear all drawings and go to the next slide. Okay. So first one is pictograph, and each symbol frequency 1. So if the frequency in a category is, let's say, 3, then you will have 3 smileys or 3 symbols to show that. Okay. Now, then what happens is, as you get data sets with larger frequencies, then it becomes difficult to show it using a pictograph. Okay. So what happens at that time is you try to combine pictograph, like each symbol or picture represents, let's say, 2 or 5 or 10 or more frequency. Okay. So if you have a data value corresponding which has a frequency of 20, then you may have 4 smileys next to it. Okay, 4 symbols. So each symbol is representing that, each symbol counts for 5 for the frequency. Now the disadvantage of this is, like, how do you distinguish between a frequency of 11 and a frequency of 12, right? Now, if you take a look at the NCERT textbook, I mean, let me see if I can dig that up for you. I may be able to. Okay. So let's see this, right? Okay, so that's okay. Look at this, right? So each bulb is basically showing 10. Okay. Now, if you look at February versus April, I mean, it's kind of shows a part bulb, and you don't know whether it is going to be, I mean, looking at the pictograph, both look like, that part bulb is representing 5, right? Whereas that is not the actual data. Now, NCERT has tried to resolve it to an extent. Okay. You see how the symbol is modified to represent 5 student, 4 student, 3 student, 2 student, etc., etc. Right? So from this pictograph, you can completely get that. Okay. Now, another advantage of pictograph is you can build it without first getting to a frequency table. For example, you want to know when you want to, create a pictograph of the birthday of each child in the class. You can give them bindis and they can go and stick it on the chart. And as each, of course, it has to be done a little properly. Then at the end, you have a pictograph. Okay. So pictograph happens as you're collecting the data itself. So that's why it's a very good one to start with. Okay. From the pictograph, you table. From there, you can discuss, okay, which month, I mean, how many birthdays, how many are born in March, how many in September, which month has, 5 birthdays, most, least, all those questions you can discuss. But then as it becomes more, then you have this problem, and, for 5, okay, doable. Now, each basket is representing 100 fruits. Okay, you can get down to a 50. But if you have to distinguish between 30 and 27, how can you? Or even if you want to distinguish between 10 and 20, can you? So this is where there's a limitation to pictograph. And that is where you get to bar. Okay. So this is not important. So let me. Okay. So that way you have a hierarchy from pictograph to bar. Now within bar, there are 2 kinds. Okay. Took a while, there is a non-frequency bar. And there is a frequency bar. These are my terminology. So if you use them elsewhere, please explain what you mean. So in the textbook, you will see something like this is an activity where they have asked children to take strips of paper and put it around their head to measure how, the circumference of their head. Okay. And basically cut the paper off where the circumference, I mean, where it kind of meets, etc. And then each of these children, they stick their strip of paper on somewhere, and it basically looks like, these will be the strips of paper, right? So it looks like a bar. Okay. So each bar represents that of one child. Okay. I mean, it looks completely like a bar, but does this bars represent frequency? No. So that's what is an example of a non-frequency bar, but they are also useful. Okay. You can find out various things from that. Okay. And in terms of bar reading, bar reading skill, etc., all of that can be done. The other one is the usual frequency bar. Okay. Then there are two other kinds of bar, and that will be other than the regular one. There is a multiple double bar and multiple bar, which looks like, okay, oops, yeah, so that would look like, and now I will change color. Okay, this kind of things are called double bar. Okay, if there are more than two, then it will be multiple bar. So for example, when you are wanting to compare things between, like, let's say language, math, and EVS scores, okay, let's say beginning of the year, end of the year, or for 3 different classes, then these kind of things help. And this is also there in the textbook. And the other one is segmented bar. It's not there in the textbook, but can again be very useful. And it can be used in place of pi. It has also that proportionality thing. It will look somewhat like, and it will be cut in the middle. Okay, so this portion will represent something, and the top portion will represent something. Okay, so if you have, let's say, multiple classes and you want to know how many children are doing good versus how many are struggling, then these kind of segmented bars are quite useful. Okay, as a teacher, to showcase the progress or assess or communicate the assessment or what the children are, etc., I have found it to be quite useful. Okay, now after this bar, you can talk about the stick, and then comes the histogram, which is, for that you have to first get to group data and then histogram. Okay, so roughly this pictograph, bar, stick, histogram would be the sequence.
The segmented bar is similar to stack bar.
Which one? Segmented. Yes, segmented is also sometimes called stacked. Yes. And again, you can choose to do it in a way so that, Excel has that, where you look at the relative proportion. So all the bars are of the same height. And again, that is kind of like the pie chart case. That helps you figure out, the proportions. Okay. Or you can have the exact frequencies, and in which case the bars may have different heights. Okay, what I have drawn is not the relative one, the actual one. Okay, so if you just look at the Excel, you will see that how it is. Okay, line graph should come in, but it is not adequately used. And I don't think there is enough examples of line graph anywhere in the textbook. Those are things that I think should be introduced. And frankly, I really don't know whether coordinate plane needs to be introduced. Cartesian plane should be introduced first before you get to line graph, or it should be line graph and then get into coordinate plane. If you ask me, frankly, I would go first introduce the graphs, because they see them. Okay, they watch a cricket match, they see that graph. Okay, as the runs grow, ball by ball, etc. I think they even have a term for it. So, children are already probably familiar with those kind of graphs from newspaper and other such places. So utilize that, and from there, basically use that to then get to coordinate geometry maybe. Okay. Again, like when you introduce this to children, it depends a lot on the children, how much exposure they have had so far, and who is introducing them, etc. Okay. Maybe class 1 will be too young, but 4, 5, why not? And 6 onwards, absolutely yes. Okay. So we are past 12 as usual. Very little homework today. No, let me give you one more homework. Okay. Okay, first one is an evil question, really evil. Okay. And it's okay if you cannot answer it. It's quite evil. Okay, the other is okay. And similarly, this one I will specify because for the mode, it's just when you have class interval kind of a frequency table and you want to calculate mean, median, mode, mean is pretty straightforward. You basically take the midpoint of each class and then you do it. Okay, so the question is why midpoint and not something else? Okay, so that's a very commonsensical question in a way, but the reason why it is evil is it requires pretty deep math to get there, to properly answer it. At least I don't know of any shortcut. The second is derive there are, for the other two, there are really ugly formulas and textbooks do not do any justice to them. Here's a formula, use it. Okay. But where it is coming from, they don't say, and it is, if you tell children where it comes from, if you enable them, they can derive them quite easily and not having to remember a very ugly formula. Okay. Fourth question is again related to mean. What are the different meanings of mean? Okay, there are at least 2 meanings, and I would like to hear your thoughts on that. Okay, and the 2 can be connected to an extent. Okay, so those of you who do not want to go beyond elementary mathematics, you can ignore 1, 2, 3. Okay, but I would prefer if you don't ignore 4. And there were, I think, 2 other homeworks before. Okay. So, yeah. So that's it from my end today.
I have a question that if you can discuss the next time. Just paste here.
What's your question?
Like some habits or some rules that we can use. I have pasted here to follow as we are using graphs.
Can you just email that? Okay, What are the good habits we should follow while using graphs? Okay, yes, yes. Yeah, that let's discuss that tomorrow next time. Okay. And please confirm, like, if you can, if we can do it on Saturday, otherwise we will do the following week. Okay. Yeah, this is a very important question, and let's discuss it next time.
Okay, thank you.
Okay. Anybody else have any other question? Okay then. Bye.
Bye.